Today's Industry Week webcast, Make Data Make Sense, Why Data Context and Quality Are the Keys to Successful Digital Transformation, sponsored by Tulip. My name is Laura Poutre, and I'm Senior Editor of Industry Week. I would now like to welcome today's speakers, Dr. Gilad Langer, Industry Practice Lead for Tulip. Dr. Gilad Langer is an accomplished business leader with 25 plus years of experience in IT, automation, and engineering service delivery, technical operations, business development, and sales. He has an accomplished track record of digital transformation to drive high levels of operational performance in manufacturing industries with a specific focus in highly regulated industries. And Brian McGarvey is an account manager at Tulip for enterprise general manufacturing customers. In his role, Brian partners with customer stakeholders to enable the adoption of Tulip at the enterprise scale, maximize value, and ensure overall customer service. Prior to Tulip, Brian worked as a strategy consultant for PwC, where he was focused on serving clients in the manufacturing and automotive industries for corporate business and operations strategy. He previously served in the U.S. Navy as a submarine officer. Welcome, gentlemen. The floor is yours.
Thank you very much, Laura. So let's start here our webinar. Quick view into the agenda. We're going to cover three topics. We'll start with a bit of background and concept about how do you create meaning from your data? We call that contextualization. We'll explain a bit about the differences between how you do that in modern digital technologies or this new paradigm that we call Industry 4.0. And we'll end up with examples, obviously, to clarify some of it and show how this really works and brings value with some of our customers. But before we start, we want to have a quick poll in terms of how you are capturing data and if you are seeing any value out of that. So please, we'll give you a few seconds here to answer the poll. It seems that more than 50% of you answering says we have a lot of inside data, but analyzing takes a lot of time, and that is something we certainly are going to address as part of the webinar. Not surprising, I have to say, because that is also what we see and have experienced. I guess I've experienced that for the last close to 30 years dealing with industry. So the question then is, how do we solve that? And that is really the essence and the theme behind the webinar here. So let's, with that, move forward. First, let's talk about what does context mean and how do we get, the basics of getting meaning out of your data. So contextualization, and we'll cover that term in a few things, just to make sure that we are clear on definition, really is about elevating data to information with a purpose. The purpose meaning that it's meaningful and we can gain insights that are actionable. And why? Because in Industry 4.0, we talk a lot about information adding value that we, first of all, can make the right decisions, but also elevate our systems to be something called predictive and adaptable. And we'll cover that as well. But that is the goal, and that is the intent of all this. So everything that we are going to cover today, again, is with the intent to say, how can we get more value out of our data by elevating it to be predictive and adapt, or making our systems and our behavior and our operations predictive and adaptable. But let's start with understanding, what is contextualization. There's something called the DIKW hierarchy, and I'm going to go over that. If I give you these numbers here, 10, 10, 2, and 16, without any further information, this is data. Now, if I added a bit of context to it and say, these numbers are actually a date. Now I've elevated data to information by simply adding context to it in the form that say this data has a meaning, that it's a date. Now I can take that further. And if I say, well, this date is my kid's birthday, that information now becomes knowledge. And furthermore, if I say, well, I am going to act on that, it becomes wisdom, meaning that if I know it's my kid's birthday, then obviously I need to go to find a present, and I know the implications of what happens if I don't. And that's wisdom. The DIKW hierarchy has been around for quite a while. In fact, over 100 years. So this is not something new. It's something that we've been using as we look at data across the board. Now, if just translating that into what it means in manufacturing, take the same example. At the bottom, these are just numbers. If I add a unit of measure to it, and I add the context that it's pressure, it becomes information. Now, if I take that and elevate more and put it in an SPC chart with upper and lower bounds, now it becomes knowledge because I know what I need to do, or there's at least an action that I need to take. Now, if I add on top of that the information saying that this always happens when I use a certain material, it becomes wisdom. I can now be predictive about it. Now, this is also very important because with just data and information, we have some visibility to things. It's when we elevate the information to knowledge and wisdom that it becomes predictive. If knowledge becomes predictive, wisdom is adaptable. Those are the top tiers or the top levels of maturity that we're striving for in a digital world. So understanding that this is what we need to do with our data is super important. Now, what happens is that we spend a lot of time in elevating data to information. So I'm going to hand it over to Brian here. Give us some more context.
Yeah, thank you. Yeah, so as Gilad mentioned, getting to the top tiers of knowledge and wisdom are really difficult. And from what we've seen with our customers and what we just saw in that poll is a lot of time is spent, cleansing and formatting that data. If you're fortunate enough to even have it, a lot of times it's still paper-based and just manually inputting that information first into something like Excel, and then getting to the cleansing and formatting portion is just as equally challenging. But that's all of the non-value-added portion of the work that you have to, a lot of times as customers are required to do to even be able to get to starting to analyze or translating that into actionable insights, which really start delivering value. And that's really where the next part of this conversation is going to go to, is how do we transform information and how do we think about Industry 4.0, and the information is fundamental into that journey of digital transformation and realizing value based on what you have and what you can extract in your operations. And so when we think about the framework of Industry 4.0, we have value on the y-axis and the journey that a lot of customers that is required to ultimately get to the promised land of value. So starting on the left, computerization and connectivity. This is the digitalization journey, which is oftentimes a lot of table stakes for a lot of manufacturers at this point. But as we'll see, it's oftentimes siloed and not necessarily integrated. But people have made efforts and have made progress in terms of computerization and connectivity. But then when we think about Industry 4.0, the next step is really the visibility and being able to see what is happening in real time within your operations. And then the next tier after that is the transparency. So seeing why is it happening, understanding why is it happening. And then even further and pushing the boundaries and extracting more value is the predictive capability that you get, and understanding what will happen and being prepared for what you're seeing on your shop floor and what's actually happening in your operations, and having that knowledge and wisdom to understand and predict what's going to be coming down the line. And then the final tier and pillar is adaptability, and so understanding what the response is going to be and be self-optimizing in that process. And so in today's world, what you really risk is becoming what we call drip, so data rich and information poor. So, as many people had mentioned, we have, a lot of information, but that data is often, captured in process historians, manufacturing, and IT systems. But, it's often siloed and captured in manual analysis, in separate data pools. So it often requires a lot of manual analysis and spreadsheets. There's lack of data visibility and accessibility when you're talking across your teams and your operations to actually be able to access the data and get insights on it. It also leads to inflexible and static reports. So if something is built, but your operations change, then it's often very difficult to adapt and change what what was valuable and what you might have started extracting insights out of, but adapting to your current operational needs. And then really what is a main pain point is the delayed insights. So oftentimes, if you do have the information, then you're looking back at what what was 7 days ago, yesterday at the very best, but you're lacking the ability to look at what's happening in real time and letting managers manage and adjust in real time. And so today we still have this problem of islands of information. So different systems that are segregated and siloed and don't necessarily talk to each other, such as customer systems with visibility and purchasing, production design, supply chains, quality, equipment, and logistics. All of these systems, people have built out. They're digital in some form or fashion, but they don't talk well and they don't play nice with each other. And so this leads to islands of information, which leads to bottlenecks of data. It's not sustainable. It's hard to interpret information, even if you have access to it or across teams, and it's not easily accessible. And at the end of the day, what we've seen a lot of customers is they've built these systems, they've invested millions of dollars with all these advanced systems, but at the end of the day, you still create a PDF and print it out. And so inherently, like this whole digitalization, there's a mentality where paper is still required, but by having that mindset, it really hinders the ability to gain a lot of insights. So now I'll turn it back over to Gilad for some additional insights on MES.
Yeah. So the question is, what do we do, right? So it's obvious we've identified that there is a problem, and we have identified that we also know the root of the problem, to the case that the fact that we don't elevate the data into information, into knowledge. But what have we done about it, right? And so the first thing to recognize is that this is not a new problem. We've had this for quite a while. I mentioned the DIKW hierarchy has existed for 100 years. Another concept that we have been using in the industry for quite a while is called computer integrated manufacturing. Stems out of from the 80s and 90s. That had to, and really it's the transformation that we call Industry 3.0. It's the automation that was introduced and the systems were introduced. At that point, there was this notion of centralizing data, meaning that we should all, the concept being we should all look at the same data from the same data set from the different perspectives that we need, so that we can make the right decisions. So that was kind of step one. The idea was things like quality by design, design for manufacture, like that when you make a decision around a product, that you also understand the implications of productions. These were very novel ideas, and to a certain extent, right? But they never came to fruition. So, around one of the things that we talk about is this MES is the source of data. We use the MES model as the context model. Many standards exist around how we should model data for manufacturing. Even modern, there's modern initiatives around how we should model the data in manufacturing to be used everywhere. And what I emphasize on that is that's the fact that we're trying to look at data from one centralized location is novel, but it doesn't work because we have multiple perspectives. And if we take a look at what perspective means, and I've brought two examples here. So way back before we understood how big the world is and how big our Earth is, everybody takes a view of their world from their perspective. On the right, you see a picture of the world taken somewhere around the 1500s, where Jerusalem was at the center of the world because of its significance. So everything was centralized around that. That made sense. That's a perspective on the world. Nowadays, we look at it and see how wrong it was. The same way that the Greeks saw the world, they were the center of the world, and everything else, surrounded them. And so, when we look at this today, that seems a bit ridiculous because we know so much more. At the same time, it was their perspective. If we take a look at how we look at data, our manufacturing data, we're actually looking at the same maps. Everybody's looking at it from their own perspective. And the point of all this is that we have to understand that data is the basis of where we may be looking in the wrong way. But let's take this a step further with understanding that. So we know contextualization is where we need to focus on. The question is, how do we contextualize? Do we do it as a centralized, or do we do it differently? So let's take this one step further in terms of the centralized model as the SIM concept advocated way back in the 80s and 90s. What we see the shortcomings are is that it's like putting a jigsaw puzzle together, meaning that if you ever build a jigsaw puzzle, you have all the pieces on spread around, and we're going to the extent to what Brian emphasizes, that we're doing the cleansing and the contextualizing. We'll take a jigsaw piece up, we'll look at it, we'll take a look at the overall model and try and see where it fits as trial and error. And we may get, it will take us time. We have to do it one at a time. And when we're done, essentially what we have is a pretty picture. Now, if you like the picture and you can use it for something, great. But if somebody comes around and takes a look at the picture and says, I don't have use for this picture, really it brings no value. And that is essentially the problem of this of the centralized approach. Now, there's good news in that digital transformation is bringing around a new way of looking at that. And it's called many things. We call it contextualizing data when it's captured at the source. And the idea is that instead of trying to fit everything into the overall model of where we think the right things are based on a perspective, why don't we take a piece of data and when we get it, add the context that we have at that point to that data. This is a concept that is inherent in most digital systems that you use. Think about you taking a picture with your smartphone. When you take a picture with your smartphone, at the time that you take the picture, it actually puts the GPS location and some other meta tags about who you did it, the time of day, and other things, and then stores it in the cloud. And if you have used these modern tools, you can actually go to the place where you store your pictures, and you can search. And you can search something like bicycle, and it will find. But it uses some other tools as well. But it also tells you when you took it and how. And if you plotted your route with your Google Maps or other tool, and you tell them, look at these pictures, it actually knows to locate where you took those pictures. And that is what contextualizing at the source means. And it's something that it makes the use of data much easier, and especially adding the context and elevating the data to information. Now, this is a modern concept of how things are done. And here, and just to emphasize, it's much quicker. It happens when you capture the data, and then you don't have to worry about plugging that data into the centralized model when it finally makes its way to the cloud, and easier to use. Now, there's all these sorts of implications that will exemplify that and how that is. But, if we take it, to the point, or maybe I explained the mindset. So I just explained a new way of doing things. We have to understand that we are, as a mindset, we have an issue culturally and from a mindset perspective, in that we tend to see everything, the end result of the data we use, as a document, in the way we capture and the way we use it. And we actually have to lose it a bit. And I always take examples of my kids and how they use data. They don't, for them, for example, a paper mail that comes in is irrelevant and of no value. They don't even open envelopes because they get all their data digitally. And when they get the data digitally, they don't use it as a document. They actually browse through it, use it, search it, etc. I was at the IMTS show a few weeks ago, and it was astounding to me to see all these different technologies that are very novel and use very modern tools, including our AI, ML. But they're all isolated. At the end of the day, when you talk to the vendors, how can I use the information? The most times they'll say, well, here's a PDF of it. So we have all this data captured with everything and contextualized, but we tend to want to see it as a PDF. Now, data in the modern system is all digital. And it used to be, when you consume it, you have to think about it, of consuming it in a digital fashion as well. As that is captured digitally, think about using it, browsing through it, searching through it, looking at it as graph, looking at it from multiple perspective. And that's also an important aspect of this cultural change that comes around. But enough of the talking. I'm going to give it over back to Brian so we can talk a bit about examples.
Yeah, thanks, Gilad. So the next couple slides here will be examples that we like to showcase at Tulip of really examples that, whether, customers have influenced this or what we've developed as kind of lighthouses of good examples of contextualizing data at the source. And so this first perspective is kind of from the operator. And for me, this really resonates and I think is a really powerful example of enabling operators to capture data at their assembly cell at the source. Because if you walk onto your shop floor, manufacturing operations, what you typically see is operators assembling something or tracking production data, right? And that's either done on paper on a clipboard or potentially even a whiteboard. So something like an hour-by-hour tracker. What this offers is allowing operators to input data at their assembly cell and provide context as to if it's running or not. So what you see in the top left is the status of their workstation or their assembly cell. And for right now, it's running. They can select that, hey, it's down, we're out of material, we're in a changeover. You start getting that context of, hey, how productive was this cell from an overall time perspective. On the right, what you see is the operator is able to input the number of parts that they were able to make, in a given hour, as well as how many defects that they had, and then report the scrap reason. So as opposed to the old way of, writing, at 2 p.m. I made 14 parts and 3 of them were defects, and kind of losing that context of what were the defects for, or having kind of I've seen cryptic, defect codes. All of that, happens in a static time, and at the end of the day, it's collected and inputted by, maybe a value stream manager and input into Excel. With something like this, it's captured in real time, and it allows managers to manage because they're able to understand if they're winning or losing, the hour or the day or the shift. But also it enables people like quality to gain real-time insights into, hey, there's these types of defects that are happening on my shop floor right now. How can we intervene? And so that's having an application like this or a platform like Tulip enables contextualization at the source from the operator's perspective, and it's extremely valuable, especially when you're also able to bring in things like and connect to your ERP. Again, like in this example, it's by work order and by SKU, you're able to get again like that type of information and understand if you're winning or losing the shift. And more importantly as well, you're also able to aggregate this data at the plant level as well. So if you had 20 assembly cells, you're able to surface that data to the managers, the value stream leaders, and they're able to have that visibility in real time. The next example is kind of taking the machine perspective. So, a lot of operations obviously have, machines of various types integrated as part of their critical operations. What this is really showing is the ability to start monitoring machines at, again, in the platform concept in real time. And that can be done through things like OPC UA and Kepware for more modern machines. And that, can monitor those types of machines and understand their uptime, performance, quality, all in real time. But, again, this platform approach and being able to allow people to provide context is very important. So, as you can see on the screen, there's the ability to say, hey, over all of these assets, how are they performing? But then being able to click into each one of those and say, okay, for a given downtime, what was the reason for that? Was it a changeover? Was it a broken bit? You're able to allow the operator to interact and intervene with the data. And again, all of that is stored and aggregated at a higher level, so you can get insights and ultimately the wisdom and knowledge of your operations in real time. And this final example is, from what we're going to call an engineer's perspective. So one thing that, we think is very important, again, is that, engineers help run, like advanced manufacturing engineers, quality engineers, continuous improvement engineers are also integral parts of operations. And so being able to empower them to have data and insights and information is extremely important. And so in this example, this is a batch analytics example. On the right here, I just want to highlight that, some of the information that you're able to start getting is, hey, by step, what is the average time by step at each station? So people are able to start analyzing in real time, where are bottlenecks in my processes? And that's in real time or over an aggregated amount of time. And that's really empowering for these types of personas and these engineers. Also able to do things like with SPC and quality, bringing in, edge devices and digital calipers, for example. A lot of our customers find that extremely valuable to understand the trends of production, of items coming off their line in real time and getting those insights. So again, these are just a few examples of kind of what we, for select personas that we wanted to highlight, but we'll get into some customer examples after this. I'll turn the floor back over to Gilad really quickly to discuss this next.
Thank you very much, Brian. So, and if you take a look at the slide, it's actually essentially what's behind me here. I am at the Tulip Experience Center. We call this Mission Control. And because Tulip is a platform that, all our customers use, we are actually looking at all the data that's, or the usage data that's going on the platform. And when you do this type of contextualization that we speak of, Then you can start gaining data that we can see kind of in the back or on the slide and in my background. This is basically a mission control. In the back end, you can see there's dots that represent activity with activity of customers or users in the platform. Now, this is exemplification, but the point is we can tap into this data set without any need to do data cleansing, information, et cetera, and plot at a high level a map of activity. And what you see is yellow dots as actually somebody in our platform building something or doing something, and the blue dots represent an operational app running on the floor collecting data. Now, the concept here is that we can tap into that data. Now, you can also go all the way down to one of these dots and see exactly what's going on if there's a blue dot. All that is happening behind the scenes because data is streaming with context into a cloud system, and now we can start performing all sorts of analytics around these things. And that is the power of digital technology, essentially. Back to you, Brian.
Thanks, Gilad. And so this next section will share a couple, real examples that are out in the real world. Some of those blue and yellow dots that you just saw that you see behind Gilad being used by real customers right now. So the first example is from one of our largest customers, Stanley Black Decker, where the problem that they had was that they managed millions of dollars worth of returns from places like Home Depot, Lowe's. But all of this was done over paper or over manual or spreadsheets, and it was very inefficient. There was a lot of waste from a time perspective of people dealing with this data, as well as just managing the types of returns. You can imagine somebody returning a drill that was sold 5 years ago, but not having the ability to kind of triage that, understand, okay, this drill was sold 5 years ago, it's out of warranty. In the old system or old world, they didn't have the ability to contextualize that data from the person that was managing that return, and they would might have to just say, okay, we'll honor the warranty, we'll honor the return. With the application that they built, they're able to manage these returns and get and provide basically reason codes in real time to say, hey, this is not based on this USN. This part was out of warranty, or it's missing this, it's missing that. And assign these reason codes so that they can more efficiently basically triage the amount of returns that they have to do, and basically say, yes, we'll honor this return, or no, this is not. So there's kind of two aspects to that: is the savings from that portion, as well as just the amount of overhead and labor burden that was reduced from having to write this all on paper and then translate it into Excel and then upload it to another system. Again, all of that is gone because you empowered operators with at the source, managing the returns, just as a simple but very powerful example that obviously Stanley Black Decker has found value at. But as I go through to other customers, it's a scalable concept, and so it wasn't unique. That their problem was not unique to them. This next example is from an equipment manufacturer who makes bathroom products. They have multiple sites where their operators are putting together faucets, shower heads, bathroom equipment, all of that. And what part of their operations in their prior state is that they have a high complexity in terms of the types of the number of SKUs that they have going through each day. So they have, around 1.2 million components processed each day through their plant. And so there's a lot of complexity in the parts that they had to request, and the material handlers picking the right parts and bringing them to the different assembly stations. And they basically were very inefficient because they would stock out of material or run out of material at the line and go line down. And it was pretty burdensome for the material handlers to find the right material and bring it to the assembly stations. In addition, the work what they had is the assembly stations would have to get up and go find a material handler and request parts. And so what this customer did was implemented a system or an application where the assembler, the operator, is able to request parts to the material pickers and the material handlers proactively. And again, bring this back to contextualization, is that with a system like this, you automatically know who requested it, what part they're working on, where that part's located. And so it really just reduces the amount of time that it takes for the request to go to material handler and the material handler to find the right part and bring it back. And it's all proactive as opposed to waiting until you run out of material. And so this has generated significant savings for this customer. It allows them to have visibility into the types of materials that's requested, the consumption of the material, the frequency of material requests, like all of this information, which used to just be word of mouth or tickets, is now digitized. And they've scaled this at multiple facilities, and it's a really, really powerful use case. Again, not unique to this customer, but it's something that is scalable to others and is other operations. Just
want to add, Brian, that on that example, I mean, if you talk to the plant manager, and see the light in his eyes that he can, how actionable this information is for him, it's kind of eye-opening to see, an operational leader use, be able to act on the data, how much it improves his daily operations in his life. So that's, all the way from the field. This is a true example, a number of factories that I've visited myself, and it's astounding.
Yeah. And to echo that, I was visiting this customer just a few weeks ago and heard the same thing. I mean, this is just one example of an application that they use. And what's really been powerful to see is that they now have an ecosystem of applications and use cases where they're able to aggregate this data, at a higher level and understand their operations holistically at the plant level too. So it's truly powerful there. This next example is from a food manufacturer who used Tulip to improve visibility across their shop floor, across their their operations. So what you can see kind of in the background is kind of a plant level view of their operation. So by line, so you see mixing and sheeting and freezing, things that you do for making food. They're able to have kind of that viewpoint of, hey, what lines are up, what lines are down, are there issues? And then on the right, also being able to see, okay, historically, like what are my uptimes, downtimes, how's my performance been, and being able to also select over time periods to see trends and to gain the insights into their operations over time. In the foreground, the bottom right is what we call like a double click. So if you were to click into like one of those, you're able to see, on hour by hour, kind of how has the machine been running? What are the stoppage reasons? What are the fault codes for that machine? That's the type of insights that you kind of get from a table stakes level of working on a cloud native platform like Tulip. And these are the types of insights you're able to just get, again, from working on a platform like this, that in the old system, at best, you might have been recording, on paper, you might have been recording Excel. And again, at the end of the day, somebody's got to aggregate those papers into Excel or into, your other tool. And oftentimes what we hear is once they've done that for the hour at the end of the day, that, there's no time to actually sit back and look at the data and ingest it and understand, how do I make my operations better? A lot of that is done, just inherently with at the platform concept like Tulip. And so this has, been able to reduce the errors, improve their yield, and reduce the scrap, particularly for this customer.
So the question is, how do we get started? Which is kind of a common question. So first of all, I want to emphasize, something that has to do with digital technology, and that's speed or time to value. If you take the monolithic approach or the traditional approach, you have, apart from the time it takes to cleanse and figure that out, just coming up with a model in itself takes a long time. And then you have to implement the model, and all this takes months and months and months, to the point where the value comes so late in the process that at that point you realize that you actually need something else. The way you do it in Tulip and with this notion of contextualization at the source is you start small and build, very much in alignment with the continuous improvement mindset. but you basically create these nodes or these apps on the floor that start to instrument the process and capture data. And with that, they add the context to the data. And you're building your data set as you go and using the data set as you build, and also gaining the value and learning from it, right? So if something does, for example, lack some level of context, well, you can go quickly back and add that context where it's needed and propagate that across that. The other thing is that there's no need for this top-down structured approach or the one model, one perspective of it. So the message here is that, two things. First of all, you can actually go and do it pretty fast right now. The time to value is very quick, and you don't have to know everything before you start, which is, I think, is a hard thing to do for most engineers, but that's the way of the modern world, the way of the digital world. So with that, I want to take it up and close the webinar with a few central points. The first one is a journey. It's a journey in many perspectives. The journey to digital maturity is one, but also the journey to transform your operations into this new digital technology or digital way of doing things. So I'd say the easy point is just start. Right, go down to the floor, start instrumenting your processes, make your data digital. Add the context of the source, with a tool like Tulip, and there's others as well. Don't think about data as documents. Think about data, as data and information in the cloud, where, as pieces of, tables or spreadsheets or searchable data. And don't forget the human. That's a very important part of our digital, the digital journey. Humans can they can very easily add context to data by just asking them a few simple questions. But also, if you help the operators do their job, they are going to give you something in return, and that's more data and more context in your data.
With that, Laura, I think we're ready for some questions.
Okay, great. Thank you. That was such a great presentation and some excellent use cases in there. Brian, one of our viewers wanted to wish you a belated Happy Veterans Day.
Thank you.
So first question is, I know there's an opportunity to collect and analyze data in my operations. How would you suggest I get started?
I emphasize this. It's a bottoms-up approach. First step is start to instrument your processes and focus on operators. So go to your floor, see where there may be a place you can digitize, or even as a challenge, a simple Gemba walk. Just identify some of the places, implement a few apps. It really does not take more than a few hours or days, and you're starting to collect data. Don't worry about is it organized, how it's organized. Just instrument the process, capture data that you need, and then look at the data. Just by simply showing the data to an operations leader, you will start to see patterns within the data if you give them the right context, and keep building on that. So that's really the starting point.
Yeah, just to add on, like one of the things I love to do is when I visit customers who maybe are less mature on their digital journey is very similar to Gilad. Get the tour, do a Gemba walk, and just see kind of where the paper is. For me, a lot of times it's very evident that like the example I showed with like the hour by hour tracking, or whether that's paper or whiteboard, what have you. Like there's so many opportunities that simple applications where you just start collecting the data will make a world of difference, just to be able to visualize that. And just to echo what Gilad said, like it doesn't have to be perfect the right time, or at the first, in the first iteration. Like you can build on it. You can take a library application, for example, from Tulip, pre-built applications, and get started, and then build and iterate on them. And over time, you perfect them, you tweak them, you get feedback from operators. That's often a really great approach that adds significant value on, within a matter of days, weeks.
Great. Brian, you kind of answered my next question, which is, can you give an example of how you've seen customers get started? Is there anything else you wanted to add? Either of you guys wanted to add along those lines, or should we just move on to the next question?
I think it's really just a reiteration. That a Gemba walk is a great place to start. Also, just understanding, just talking to your other operational leaders, understanding what are the pain points, because oftentimes there's a relatively simple application that you can get started with, start collecting the data, start kind of unweaving the ball of yarn, to start pulling the thread and start understanding what's going on and getting those insights. Again, it doesn't have to be perfect on day one, but you start small and then you iterate, and it's incredible to see how fast customers can get started, adopt a platform like Tulip or others, and truly do get value out of it. Like it's great to see.
Just a quick note. Another point would just to go to the whiteboards or the boards in a plant where people print things and stick them to the board. Right, that exists everywhere in every plant. The visual management boards, that pick one of those. Let's start digitalizing.
Great. Another question from a viewer. We have a similar situation relative to the data input capture you are showing. They use a customized version of Plex. The disconnects not only happen when you are working with PDFs, which they seldom use. Most often it is truly real-time across the global organization. But the lack of ability to tie in training and visual alerting training, does Tulip incorporate these types of activities within their platform?
If I'm hearing this right, I mean, Gilad, back me up, but I'm kind of hearing, is it kind of like a skills matrix and training matrix? Like, is that, I'm kind of assuming that's where we're going with that question. I'll just answer first, and Gilad, you can back me up. I'd say absolutely yes. Like there are use cases and applications for using Tulip to help manage skills and training. Taking that one step further, one of my customers I work with has integrated that skills matrix app, skills training app, with they are using Tulip as their MES, and they've integrated those two apps together, which again is a great to see, where if an operator is going to go do an operation, they're signed in, it checks against that skills matrix, and if they're not qualified to do that, then it blocks them from proceeding. And again, other customers have used that as well. Again, one of the core principles of that is reducing safety incidents. So some operator that has not been trained to operate a piece of machinery or equipment really isn't allowed to do so unless they've been trained properly. And so that's been a game changer for a couple other customers as well.
Yeah. So to add to that, remember, in the digital world, you're not focusing on one system, but multiple systems. So the problem that you're mentioning here is that there's one system that's monolithic that wants to put all the data in its model, and then there's the disparate data around other places. The idea is that once you contextualize the data at the point that you get it, and now make it available to be viewed by a multitude of other ways, and that's, I think, the core of it, right? One is capturing the data, the other is making it available for you to use in the way that you want to use it. So there's a bit of kind of an old and new world here. And I think that's part of the problem that if I read through the question here.
The next question is about contextualizing data. By contextualization at the source, it enables faster decision at the location. But when it comes to the executive team, some kind of data definition probably will still be needed. How does your system deal with federated data? Yeah.
So here, it's a very good question. Federated data means that you're putting data into a central model. So the whole concept behind this is that you don't necessarily need to federate data. That doesn't mean that you can't if you want to. But the idea is that once the data is provided in the form where context is added to every single data point, then you can put it into a centralized model if that's what you wish. And sometimes there's value in that, as you mentioned. To do certain types of reporting and drill downs, there's maybe a place for that. But even the federation becomes simpler, is kind of the idea. And so, yes, Tulip, it's not that, Tulip, the data in Tulip is accessible through a public API, with the context that has been collected with it. And you can do with that whatever you want. all the way to AI ML type algorithms, move it into a data lake if that's what you want, or move it into a traditional data store, data warehouse where the data is captured with a very rigid model.
Okay, great. Thank you for that answer. Another listener is wondering whether a solution like Tulip would replace their current system, or does it integrate to improve what they're already doing?
Well, I guess both is the idea. It depends on what that system is and what you want to do with it, right? In general, I would say that, when you look at, Tulip needs to be looked at as a tool to help you become, more predictive and adaptable in the way you operate. It's a digital tool that helps you increase your productivity. The question is, where do you want to, where and how? If the system that you have is old and you can't do anything with it, you can use Tulip to augment it. You can use Tulip to replace it. You can use Tulip as a supplement to it to add more data to whatever the system is. And so really it depends on the process, the operation, and how you want to increase your productivity.
Yeah, and to add on to that, I think this is like one of the great value propositions of a solution like Tulip specifically is that, it's an open platform. So integrations and passing of information between systems is meant to be easy. So to the point of supplement, that's absolutely possible. And I think is makes tons of sense depending on the situation and context, but it can replace, it can supplement either or.
A specific technical question here. To integrate with Tulip, does the machine on the shop floor need to have API capability?
Yeah. So yes, depending on the, we support a number of standard protocols, starting with OPC, MQTT, MT Connect, and a number of other industrial platforms. And that's how you can integrate. You can also integrate through an API if that's what you have. All the way to actually, we also provide hardware as part of it. So if there's machines that are not connected, you can implement one of our edge devices and add sensors to it to help you capture data.
Are you replacing those silos that you showed at the beginning of the presentation, or treating these silos as sources?
So I would say both, right? Some of these silos also with them have a lot of legacy, a lot of good data, and a lot of investment in it. So, replacing them probably takes a while. We can use them as sources. We can replace them. Really, what matters here is to digitize the data and provide it in a way that it can be consumed to add value to your production. So yes, we can tap into that data and add additional context to that. But again, Tulip is not the only way you can do that. If you have data sources, you can use Tulip as a data source, tap into the existing sources that you have, and use other types of digital technologies to do simple dashboarding to advanced analytics with AI ML.
Another viewer is wondering whether the only hardware that's required for Tulip is tablets and screens, or do you require other hardware as well?
You can do tablets, screens, a typical desktop PC, your Android or iPhone. Sky's the limit. It's pretty open, but again, it's digital, so it's not whiteboard and paper. So.
And can Tulip analyze video operator data? Is that on the roadmap?
Well, more than that, it's actually a feature. So we have a part of the platform that's called Vision. We can spend a lot of time explaining what it is. I would recommend that, to go to our website to see some of the capabilities. Just think about, we can connect to any camera and use that as a source, including detectors to detect things that the camera sees based on a configuration. It's all no code, it's pretty easy to use. I think there's plenty of information on our website. And of course, contact us and we can talk further.
Do you have any example on using edge equipment to do data learning? This listener is interested in using a laptop to do some data learning.
That question is a bit hard to interpret. It can be interpreted in many ways. So, when you're learning, we're talking AI ML. There is features in the platform to do data at the edge as well as in the cloud. If you just mean data learning, any of our, once you have the data digitized, the data is available and looks like a spreadsheet, and you can create charts and graphs and in the same ease that you would use your Excel data. I don't know, Brian, do you have anything to add? That was my interpretation.
So yeah, I think the answer to the question is yes, but it kind of depends, and would love to learn more about what exactly the individual is thinking. There are opportunities to, for customers to train their own models, integrate that with Tulip. We do use we work with AWS and Microsoft and with some of their AI ML services and models as well. But Tulip is a very open platform, so there's a lot of possibilities. So the answer to your question is yes, but would love to learn more and to have a conversation around that.
Another listener is wondering if there's any applications for educational facilities, or is the platform just for industrial applications?
So like one of the use cases is that a lot of customers use is like work instructions. So with Tulip, you can embed rich media. Some of that is, CAD models, for example, PDFs, but also videos. So like if one of the mediums that the educational facility is maybe potentially trying to use is like, hey, I want to teach somebody based off of videos or a process on a video, before to qualify somebody. Like if that's where we're going, like, yeah, absolutely. You can use Tulip to embed videos in that way, if that's the nature of the question. If it's to train somebody, like before, if it's a training pipeline, so somebody goes to a central location to get trained on, I don't know, repairing a motor, and then they're going to go off to somewhere in the world to actually do that, then something that Tulip can help with is that Tulip is used for is building guided work instructions. Again, very similar to what I mentioned, but it's helping new operators through a process and teaching them. So if that's where the question was going, then the answer is also yes. But again, if it's not, would love to learn more and understand the question further.
Just a couple more questions here. Do you see any limits for what type of data you can collect?
No, there is. I mean, when you say limits, the data that we know, everything from videos and pictures to simple data, like a data point, it's all very easy to collect in Tulip. Yeah,
and like videos, pictures, sensors with vibration, humidity, temperatures. The sky is really the limit in terms of what you can do. And it's, again, something that's been amazing to see is how, the creativity and how customers have used Tulip to solve, unique problems, or, think about something that is just quite amazing in terms of how they use the platform to solve the problems that they face and it really provides value to them. So
maybe just a quick example is that we have a lot of customers that one of the things that they do is take a picture before, when they send ship a package, they take a picture of what's in the package, because then when customers come back and say something is missing, they look at the picture and show the customer the picture, say, hey, it isn't. That's a simple, just an anecdotal kind of an interesting example.
We have time for one last question here. Does Tulip have a built-in SAP connector to pull data?
Yes.
And it's in the library, by the way. So you can actually look at a Tulip library. That's where we have content share, and you will find it there.
SAP as well as many other systems. Just to add on for everyone else listening.
Well, great. Thank you so much. That was an excellent presentation. Really appreciate all the examples that you shared. I'd like to thank you, Dr. Langer and Brian McGarvey and our Tulip team here today. On behalf of Industry Week, I hope everyone has a productive remainder of the day. Thanks so much.
Thank you.
Thanks.